pavement, in the second or third year, things of that nature. Those are red flags that may indicate that it's not a good candidate for this process. So again, do your due diligence. If you're unfamiliar with where a rut filling treatment may work good for you, don't be afraid to call an industry. There's technical advisory committees and things of that nature that you can find at slurry.org. We've got great technical support, and we always have somebody close by that can probably come out and take a look and give you some advice on a roadway as to whether it would be a good candidate for rut filling or not. So again, the whole idea with rut filling and scratch coursing is to reprofile those wheel ruts. And when we talk about rut filling, for each inch of applied microsurfacing, rut fill mix, add 1/8 to a 1/4 inch crown to compensate for return traffic compaction. So it's hard to see here, but you want to slightly crown that rut filling application so that when you return traffic to it, you get that little bit of consolidation and return traffic compaction, levels that out. You want at least 24 hours of traffic on that pavement or on that rut filling prior to putting your final lift, your final wearing course on that. And again, these are on ruts that are over 1/2 inch, and you will use a specifically designed rut box to apply that material. So a cross section of what a microsurfacing filled rut may look like is this here. You can see we have our high parts here, the depth of our rut here, another high part here. And again, we don't want to build up here. Just some slight matrix and some fines. We don't want that. But this spreader box that we use for rut filling is V-shaped configuration. And what it does, or what the goal is that it channelizes the largest particles of aggregate that I'm pointing to here to the depth of the rut where the most stability is needed. That's extremely important. And again, wiping it thin on the high spots. That's the whole idea. That's what we're trying to achieve when we fill ruts with microsurfacing. Okay. If the pavement is structurally inadequate, a microsurfacing treatment will not provide adequate structural improvement or prevent further deterioration. If the ruts have extensive alligator cracking like this picture here does, and shear failure, or result from another serious underlying pavement problem, the pavement can generally be considered structurally inadequate, and filling the rut will not correct the problem. So if you see something like this, and in this particular job, this was prevalent throughout the entire length of the project. It was not just an isolated area that could have been remedied by a full depth patch or something like that. So this is when the agency needs to make a decision on the very front end in the design phase that this is either a good candidate or it's not. And in this particular case, it's not. Again, setting the crown. This is what the rut process looks like. You can see they've got a rut box here, got the material. They've done the outside lane first, or the outside wheel path first. They're doing the inside wheel path second. That gives you a little bit of a shingle effect to help that water flow from the center line towards the shoulder. And what's really good about this picture is you've got this guy with this 10 or 12 foot long straight edge, making sure that they're filling the rut, making sure that they're adequately crowning that rut so it'll take that return traffic compaction and be just like they want. There's nothing worse than going out and filling ruts, not getting them filled, or overfilling them and creating a hump and things of that nature. So need somebody walking behind it, double checking that crown pretty much all the time. Contractor's doing a fantastic job in this picture. All right, let's look at the rut filling process. This is before. You can see you got good consolidation ruts down through here, holding water, obviously an unsafe situation, needs to be remedied. It was determined that it was a good candidate for rut filling, and the agency bid the job. Contractor comes in, fills the wheel path rutting in picture number 2. You can see picture number 3. This is that V-shaped configuration I was talking about earlier. This is great. It's got these augers, or in this particular case, paddles, that channelize those larger particles of aggregate to the center of the box, which is centered over the depth of the rut. Um, and that's where the most stability is needed. Another thing I want you to recognize is the mix itself. There's not a lot of free-flowing liquids here. It's a good homogeneous, thick mixture. This is what you want when you're filling ruts. This is a great job being done. And then as an end result, this is what it looked like when they started. This is what it looked like during the process. And here's the end result. That's a tremendous benefit to that agency and to the end users that drive up and down that roadway. And it can happen quick. That's what's so nice about it. These projects they can typically be designed quickly, bid quickly, completed quickly, and that way that pavement is either preserved or repaired back to its good condition in a very short period of time. So very advantageous when you go at it that way. Now, when you don't fill ruts well, like we have on the left, there's a problem. And I realize that's an old picture. It's probably not representative of the kind of work that goes on these days. It's an extreme example of what not to do. So keep that in mind. But what's on the right, you can see they've done a great job. They've filled each wheel path independently. They're good. There may be a little bit bigger gap in there than what I might typically care for. A lot of times those passes are touching each other or are extremely close, depending upon lane width and rut configuration. Ruts can be extremely wide in pavements, and sometimes they're a little more narrow, and you need to set up your box to fill the rut that is there. So little flexibility in addressing those ruts is definitely necessary. So rut repair requires a contractor to slightly overfill the rut, like we talked about before, 1/8 to 1/4 of an inch per 1 inch of rut depth. It's advisable, again, to have at least 24 hours of time under traffic before placing an additional lift on top. Now, a lot of times, and it may just be the type of work that we get when we're filling ruts, we typically go through the entire project, fill all of the ruts, whether it be a leveling course or a rut filling course. We like to do all of our level up first. That makes sure that we have adequate materials to do all the filling, and it also gives you a little extra time of traffic on this material before you start placing your final lift, which is really important. So that's how we typically do that. Areas with deep ruts often appear slick or just have a little bit of lack of surface texture because that aggregate is 100% embedded rather than the 80 to 85 that you'll typically see on your final surface treatment, and they lack surface texture because of that. So the appearance is normal under the circumstances and will be taken care of on the surface treatment. Good to know that. Ruts not filled under separate rut filling procedure will affect application rate. So if you've got 3/8 of an inch deep ruts and you're not doing a level up, or of course, if you've got 1/2 inch ruts and you're not doing something to address those ruts and try to take care of it in one lift, you're probably going to be somewhat disappointed with your surface texture uniformity, because you're going to see some of that aggregate that's 100% embedded because you didn't fill those wheel path ruts prior to it, and you may even see some water ponding as well. So it's important, again, right treatment, right road, right timing, and make sure you do your due diligence when picking projects. If you need leveling, or whether it be scratch courses or rut filling, just make sure you put the material in there and do the job properly. Okay, now this comes from the back of the ISSA A143, and you can see here it does actually show that slight crown that we're recommending that you build in, that 1/8 inch to 1/4 inch crown when filling a wheel path rut. And it also gives you a little rule of thumb on how many pounds of aggregate per square yard may be necessary to be installed to fill a certain depth of rut. Now this is, again, it's going to vary based upon geographic location, aggregates, their specific gravities. There's a lot of variables here. Just kind of a rule of thumb. Again, what I recommend to designers, if they have questions about this and are unfamiliar with the process and need some help, contact industry. They can help. They're typically familiar with locally available aggregates and historic application rate numbers and things of that nature. So again, don't be afraid to pick up the phone call, send an email to the ISSA Technical Response Committee, something like that, and you can generally get some good information that'll help you with your decision-making process down the line. Now, let's talk about surface texture. Existing surface void content will directly affect the laydown rate of the slurry system. The more porous the surface, the more material must be placed to satisfy that surface demand. I typically call that hunger factor. If you've got a coarsely graded chip seal product out there, it's going to require more material than a densely graded roller compacted hot mix asphalt. The percentage of voids on the existing pavement is affected by many factors, such as size of the aggregate in the existing hot mix asphalt, fines in the hot mix asphalt or loss of fines in the hot mix asphalt, density at laydown, again, the texture of chip seals. There's a lot of influencing factors that will have an effect on the final surface texture, and the existing surface texture of the pavement you're going over is definitely one of those things. When the existing surface is badly raveled or otherwise coarse and open, more material is needed to fill those surface voids. When the surface is nearly smooth or flush, less material will be needed. Sorry for the redundancy there, folks, but that's ultimately a good point. You have to know what you're going over, build it in the design process, and know how much materials you should need. Okay. Adherence to the job mix formula aggregate gradation is critical. So we've done all this hard work and effort on the front end. We've taken all the component materials that we're going to use on the project, and we've sent them to a lab for extensive evaluation and performance testing. Okay, that lab has developed a job mix formula for us that says that if you will mix these materials in the proportions that we are recommending, you will realize performance. Okay, so back to that important thing. Mix design, very important. Calibration, very important. Test strip, very important. Okay, we have to have those things. But often the designated aggregate gradations may vary in particle size. For example, type 2 aggregate from one supplier may be finer than a type 2 aggregate from another supplier, and this could easily be applied lighter. Again, we're not switching aggregates here, but the point I'm trying to make is that mix design, once it's submitted, it's kind of the rule of thumb. The tolerances on the aggregate stockpile should be recognized. You want to make sure that the aggregate that sits on the job, again, is within the tolerances set forth within that mix design. You don't want to be using a gradation that is 10% off of what was submitted in the mix design process. Each sieve has a tolerance and should be verified to make sure that the aggregate on the stockpile meets that tolerance. Aggregates also may vary in unit weight, and thicker applications of one rock may actually weigh less than a thinner application of another. So quarry to quarry, specific gravity to specific gravity, all kinds of things can have an effect on that. Surface texture is going to affect the application rate. Again, a smooth surface does not have many voids to fill and thus keeps the spread rate lower. A weathered, raveled, or open surface will increase the spread rate as material fills the voids at the same time it's covering the surface. Surface textures will often vary on the same road between traffic areas and shoulders or centerline areas. Application rates will vary with surface textures and thus may across any given cross section of the pavement. So there are going to be some subtle differences out there. Don't get me wrong, application rates, once they're determined or once they're specified, they can generally be dialed upon or dialed in pretty closely. The longer pulls you make, the easier that is. If you're doing a lot of stopping and starting, maybe a little overlapping, that's going to vary a little bit. But it's just important to stay on top of that and know what you're doing and know what affects it and make arrangements to counteract some of those negative effects that you may encounter while installing your treatment. Now, final surface texture. Here are some of the factors that influence the final surface texture. Now, again, the existing pavement surface texture that we just got done talking about, very influential on final surface texture. Mix consistency. Do we have a good accurate calibration? And beyond that, is the operator up there juicing the material up with more water than it needs? Is he running additive when he shouldn't be running additive? Is he trying to go too fast down the roadway? He wants to make sure, you want to make sure that the mix is consistent, and through the accurate calibration process and setting the machine up properly, you should be okay there. But you have to stay on top of it. Again, adherence to the job mix formula. We don't want to be doing stunt operating out there. We don't want to go outside of those tolerances that we just talked about. We want to make sure that we stay inside of those. That's the performance evaluation information that we have at hand, and that's really what we have to rely upon. It's not for an operator or a job site superintendent to determine that, hey, we need to run outside of that job mix formula because it's going to provide you a better product. No, that you need to stay within it. The type of screed rubber used, in a spreader box, which Dave's going to talk a little bit about that later in the presentation. The spreader box maintenance, an ill-maintained, uncleaned spreader box is not going to apply the material as efficiently and as proficiently as one that is maintained well. Use of drags and a secondary strike off. Again, burlap drags, canvas drags, things of that nature leave a certain surface texture, just like a secondary strike off does. There's options there. Ultimately, uniformity is what we're looking for, and contractors are typically very willing to work with the agencies to determine what is the most desirable surface texture. So keep that in mind. Application rate has an enormous effect on your final surface texture. A large stone applied too thin is going to be very coarsely graded, very open graded, with a lot of aggregate particles more or less sitting on top of the surface rather than having the 80 to 85% embedment rate that we talked about earlier. It's important that the application rate fits the aggregate that you're installing. Gradation of the aggregate. Is it a type 1 slurry seal, which is extremely fine, or is it a type 3 slurry seal or microsurfacing, which is a 3/8 inch top size stone and the coarsest material used? So that definitely is going to have an effect on it. The speed of the application machine. Not as big a problem as it used to be 25 years ago. The equipment's gotten a lot better. The spreader boxes have gotten a lot heavier, and therefore the speed of the machine is not as critical as it used to be. There are some instances where it may still be something that needs to be watched closely, but in most cases, not an issue. With those lighter spreader boxes and equipment moving too fast, the potential for washboarding comes up, but also the use of an unmaintained or properly maintained spreader box can cause the same thing. If the box is vibrating and jumping up and down as it's being pulled down the road, probably not going to leave you the best surface texture, and may put some washboarding into the material when you're laying it. So you kind of have to watch that and adjust the box accordingly. Opening to traffic. Opening to traffic definitely has an effect. That return traffic compaction or consolidation is big, and opening to traffic too early can have a negative effect. So contractors are generally pretty good about knowing when the roads are ready for release of traffic, and they're responsible for making sure that it is. So that's pretty important. Let them make a choice. And then rolling if required. And rolling like tack coat is typically not required. Only time we see rolling is typically in parking lots and airport runways. They're used to simulate the traffic in those areas, but on roadways, you get that simulation without using a roller. So again, surface texture uniformity. You could see it here. This picture on the left is one of my favorite pictures. You see a lane that's been completed. Great uniformity of color, great uniformity of surface texture. You can see they're applying the material here. Great curb line, alignment, great joint. You can see they've been using their spray bar. There's just a light, damp area down the center of the road that went all the way across the road to make sure that you get assurance of a good bond there. But then when you get closer to the surface, you can see how, I guess you could call that aggressive, that it can be. So we do have an aggressive surface texture, and when applied properly, will maintain high friction surface texture for the duration of the useful life. You know, we've been doing friction studies for a long time now, and in the NCAT Min-Roads Preservation Group study only confirms what we already knew, that these treatments possess fantastic friction numbers throughout their entire life. You know, we're going into our 10th year on Lee Road 159 down there, and all of the friction numbers to the slurry seals and microsurfacings and chip seals are extremely acceptable, and not even in the realm of being considered low. So great friction values in all different traffic settings, and this is why, because we've got good macro and micro texture to our treatments. We talk about surface texture uniformity. We don't have it here. This is somewhat problematic. You know, I wish I was in front of the crowd where I could get some responses back on what they think actually took place here. But either way you look at it, the contractor was struggling here. And not only was the contractor struggling, the contractor didn't recognize that he was struggling, or didn't seem to care, and kept on applying this material. You know, drag marks are prevalent. You know, these are gouges in that pavement. You know, it's fine here, not good here. You know, you're thick here, you're thin here, drag marks, you're open graded here. This contractor did not have control of their material when applying it for whatever reason, and should have stopped, made it right, but they chose not to. This is not what we look for in a finished product. This, however, is exactly what we're looking for. You know, you got great alignment, you got perfect surface texture all the way across the width of the mat, using a secondary strike off, no free flowing liquids, no leaching of liquids out of the edge lines. This is what we're looking for here, folks. I can't say that this crew could have done it any better in this particular instance. Properly applied slurry treatments will have the largest stones embedded at 75%. We said 80 to 85 early, somewhere in that range is good. Treatments placed too thin may have drag marks and possibly even bare areas where the spreader box has pulled all but the finest aggregate and emulsion off the higher areas of the pavement. During placement under this condition, the larger aggregates can be seen accumulating in the spreader box as the unit proceeds down the street. This will make handwork at the end of the street extremely difficult and unsightly. In fact, it will make it impossible. So when that box stops at the end of the road, they need to pick that material up, remove it in a proper fashion, place some more material there that can be handworked in a proper fashion, make look to where it's sufficiently close to what was box applied. Application rates. That's another thing. Again, we're jumping around, cherry picking. Uh, get that inspector's manual. You have all the information available to you. Okay. Again, primary factors that determine optimum application rate: aggregate gradation. What's the size of the stone we're using in the material that we're applying? And the existing surface texture. What's the void content or the hunger factor? You have 3 different gradations available for slurry seal. Type 1 being the finest, type 2 being the middle range, which is probably more prevalently used across the country. And then you have the type 3, which is the coarsest material. With microsurfacing, no type 1 available, just type 2s and type 3s. Those gradations for slurry and micro, both the type 2 are identical gradations for microsurfacing and slurry seal. Now, it's important to know that slurry seal application is designed for 1 stone thickness. We talked about that a little bit earlier. And you can see here in this green box what that 1 stone application looks like. So slurry seal doesn't have the stability where you can stack those stones on top of each other and maintain performance. You may get by with it a little bit in low volume traffic areas, but ultimately slurry designed for 1 stone thickness. When we get to microsurfacing, we can stack those stones. And in this particular example, you're looking at a 2-lift situation or a multi-layer application, potentially a scratch course with a surface course. Now you're using a 3/8 inch stone here, or 3/8 of an inch in thickness of the material. You can see that stones are stacked. After you've had return traffic compaction on that, you can come back in and put that 2nd lift on it, and you'll have that road level. You have great friction values, good uniform surface texture, and everything will be as desired. Yield checks. Yield checks are extremely important. Performance of slurry seals and microsurfacing can be directly related to the application rate of the material. Applied too thin, it's going to wear out too fast. Applied too thick, it may flush on you and may not have that good uniformity of surface texture that you're looking for. So yield checks are made by comparing the area covered by the quantity of materials placed. This is an example of a yield check, determined through the use of material factors established during calibration. Again, this is just a quick note to give you an idea. The calibration presentation that's going to be available to you guys will get far more into the weeds on this, but ultimately this is a good check, and this is something that you'd want to do at the conclusion of a test strip as well, to determine what your application rate was, to see if there's any information or any adjustment necessary to meet your application rate moving forward. So we've got a 500-foot long area by 12 foot wide divided by 9 equals 667 square yards. Okay. We start with a 0 on our aggregate counter, on our proportioning devices on the machine, or metering devices. After we've laid that test strip, we've got 398 aggregate counts on that counter. Okay. So we're going to take 398 counts times the pounds of dry aggregate per square yard. And again, I just pulled this off of a calibration that I have in my files, and I know that we're getting 33.45 pounds of dry rock for every 1 count on that counter. So I'm going to take the 398 counts times the 33.45 pounds of rock per count, and it tells me that I've installed 13,313.1 pounds of dry aggregate over that 667 square yard area. Okay, so I'm going to take those total pounds, 13,313.1 divided by 667 square yards, and it tells me that I applied that material at 19.96 pounds of dry aggregate per square yard. Boom. If we're shooting for 20 pounds, we are all over it, and that's considered successful. Now again, that's going to vary as you're going down the road, but that is an example of what a yield check has looked like. We typically recommend that the agencies perform at least 4 of these per day. As a contractor and with new equipment modifications, this is something that we monitor on the fly, constantly. We're not just looking at it 2, 3, 4 times a day. We're looking at it all day, every day, because that's how important it is. So again, just an example of what a yield check should look like, and make sure that you agencies performing oversights do this on a regular basis. The inspector should monitor the project daily to track the amount of materials being placed. The preferred method to check application rate is the one I just showed you. Dividing the weight of materials by the area of treatment gives you the actual yield or application rate. Backup data, now this is important, backup data may be obtained by tracking material deliveries, less any materials left at the end of the project. So there's kind of something that you can fall back on there as well. So if a contractor says that they've applied 1,000 tons on a job based upon their calibration factors, but they've only brought in 850 tons of rock to the project, then there's something that may not be syncing up there. So there is a backup way to somewhat verify those installed quantities. And more important than anything is just staying involved with the oversight process, working with the project manager, superintendent, or equipment operator, making sure that we stay on top of it on a daily basis and not wait till the end of the project to try to work out any potential concerns. Now, this is the end of my portion of the presentation. I want to thank you for your time and attention, and I will be back to answer any questions at the prescribed time down the line. And right now I'm going to pass it off to Dave Kaiser with Terry Asphalt